we're live. Excellent. We're back. We're back. Can you believe it? I'm back in my classroom. I don't like it. I'd rather be at my desk at home where I have more features to share with you rather than just like, hey guys, we're here. Yeah, kind of thing, But anyway, yes, I do have a quizzes up behind me. And yes, you can't see the number just yet because of the giant glare that is right there. I understand that. I'm giving people an opportunity to kind of jump into the live stream first before we begin doing what I need to do. So, a couple of reminders as we're moving forward. Number one, yes, I have you Tuesday, Thursday this week. Yes, I'll be teaching from my classroom. Ridiculous. Yes, the COVID numbers are still going up. Who would have thought? Anyway, beyond that, the next few weeks are going to be weird, dude. They just are. Because, like, we got this week. You can't see it. I'm looking at a calendar right now. We got this week, and then we got 2 full weeks, and then we got, like, a shortened week, which is going to be messed up because of something that's coming up. And then we got Christmas break. But, everyone's going to be quarantining. I've already gotten multiple emails from parents being like, my kid will be quarantining until January. Great. Quarantining until January. That sounds fun. I can't quarantine till January, but whatever. That's where I'm at. Also, you guys are welcome to revel in my bow tie because it's Tuesday. So there he is. I know I do that all the time. I'm on my personal channel and then I comment and I'm like, oh crap, and then I gotta switch back. So it's one of those things. But I digress. My goal for today. The title of this lesson, if you looked at the YouTube title, Polynomial Graphing Continued. We started, thank you. Sorry, this is a bow tie, it's a real bow tie too, just so you all know. It's actual tied, But anyway, where was I? I lost my train of thought because I got thinking about bow ties. Because it is Tuesday. You got to wear a bow tie on Tuesday. Go figure. But I want to finish polynomial graphing, something that we started last week. Last week, we did a bunch in terms of polynomial graphing attributes and things of that nature on Wednesday. And we were able to knock that out. And now I want to put that into practice. Now, this, to be very, very clear, this is going to be a practice quizzes. This is a practice quizzes. This quizzes that you are going to do for me in class today will not count. I want to see where we're at. A lot of these problems are dealing with exactly what we did with polynomial graphing. I am going to suggest that you have those notebooks ready to go, out and open, to reference in regards to these problems. I can see your chat going. You guys are going nuts on the chat right now. I don't know. It's a little weird. They're just naming random food objects. I don't get it. Whatever. You know what I recently discovered? I've known for years that cold pizza is delicious, especially dependent upon which pizzeria it's actually coming from. I would argue that Naples has the best cold pizza. But I've also recently discovered that cold burritos are also phenomenal. Anyway, you guys in the chat, I'm going to have to put you in timeout or something. Anywho, so let me give you the code because you can't see the code right now because it's covered with that ball of light. But what I'm going to do is I am going to type in that code into the chat, and I am going to write it on the board just in case. Make sure I got that number correct. Chapow. That's the code that you need. The code that you need is 327319. That is the code that you need. I need everyone right now to go to that quizzes. I can already see people have already popped in right there. I need you to go to that quizzes site. I need you to type in that code because we're going to get started in a few minutes. Now, again, this is on polynomial graphing. You're going to need those notebooks to reference, especially with some of the information that I gave you last week. This is meant as a practice to see where we are at. Because obviously we are soon and very soon going to be wrapping up this chapter. And with wrapping up this chapter comes a major assessment. That major assessment is on the way. Get ready. Get ready, get ready, get ready. I haven't decided exactly when it will be, but most likely it will be somewhere near the end of next week. Just so we're all on the same page. Anyway, so far I have 6 people who joined. Make sure that you're joining that thing. 7, I heard another pop. There it is. Another 7 right there. There's 8. Get in that quizzes. Let's see who's going to win. I don't know. Now, what I've done for this quiz is I've changed up the settings, so you will be able to see whether or not you got the individual question right, and you should be able to review. You should be able to review after it's done. I got you. Anyway, I got 9 people in so far. He says it's loading on his. It's all good. Now, even if I were to click start right now, you would still be able to join in the middle of the quiz because the code would be written in white near the top right here. So you would still be able to join, no worries. I got 12 people in the chat right now. I only got 10 people over here. What's going on there? Anyway. All right. So if you have not joined, now I got 13 people. If you have not joined yet, you can join in the middle of the quiz. I'd like to get started sooner rather than later, obviously. I typed the code into the chat right there. You can see 327319, and I wrote it up there. And once I click start, it will be at the top of the page. So if you have not joined, make sure that you are going to join. In fact, let me just throw that in there. If you haven't joined, join with the code at the top of the screen. 327319. Boom. Okay, I'm gonna click start, and we'll get this thing moving. Again, make sure you're looking at your notes. You have your notes as a reference. Here we go. Jessica, I hope you saw my response. I don't know if you're still looking at the chat. I'm going to give you guys another couple of minutes, but only a couple of minutes because I would like to review as many problems as I can from this quizzes. I anticipated what the possible percentages would be on this quizzes. So don't you worry. You have only seen one class period of information on graphing these polynomials. One class period. And it was over a 4-day weekend since you have seen it. So again, I did anticipate that this would go the way it did. Like I said, this was just practice. This was a practice to kind of see where we're at. And like I said, I mean, it's been a weekend. You know, it's been how many? Actually, it's been today's what, Tuesday? So you guys learned this stuff on Wednesday. So it's like Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. 6 days. Why did I even have to count that? I don't know. Just one more minute, and I'm gonna shut it down. That's okay. We'll see in a minute what you guys got right and what you guys got wrong. That's what's so wonderful about these quizzes. I can get immediate feedback as to where you guys are at. Okay, I'm gonna shut it down. Let's see here. And all right. Click. Woohoo! All right. Now, there are a various number of problems that I would like to talk about in regards to this quizzes. Now, this definitely being one type of problem, and I will return to that in a little bit. Nice. I just like looking at what some of you guys got. I'm looking at these questions, seeing which ones you guys did really well on, which one did you not do very well on, that kind of thing, you know? Okay, so here's what I'm going to do. I would like to, what if I click this, what will it do? Can I hide them all? Yes, I can hide them for all time. Good. So what I would like to do is I'd like to go through them, not necessarily one at a time, but like a few at a time. And then I have some notes that I want to give you guys on that. So we'll figure it out. Anyway, which of the following could be an equation of this graph in factored form? In fact, can I actually see a better version of this? I think I could. Give me 1 second. I think I can find a better version of the way that the thing looks. Reports, clicking that thing, polynomial graphing, view the quiz. Will it show me the flashcards? Come on. Load better. Oh, sweet. Okay, this one's better. Good. I got a better one. Let's see. Chapoo. There we go. I got you. Well, I mean, also you're learning from home, but anyway, so let's take a look at this thing right here. Now, if I'm looking at this particular problem, now I know there's a little bit of a glare. I do apologize for the glare, but this is probably the best visual version of this that I can see. The question says, which of the following could be the equation of this graph in factored form? Factored form. Well, what can we identify from the graph? We can identify zeros of the graph. We can identify zeros of the graph. There seemingly is a 0 right here. There seemingly is a 0 right here, seemingly here, and seemingly here. It seemingly has 4 zeros from what I can visibly identify. 4 zeros. Now, looking at that question, yes, it has 4 zeros, but look at the end behavior real quick. Look at that end behavior. What do you notice about the end behavior? Mind you, I'm going to answer my own questions, but I just want you to think about it. What do you notice about the end behavior? They are going in, ready? Opposite directions. Yeah, I went there. They're going in opposite directions. One end is going up, one end is going down, indicating that the degree of the polynomial should be odd. It should be an odd numbered degree. Now, regardless of any of that, it's like, okay, but I only see 4 zeros here. Well, again, according to the definition, if you had, let's say, like, I don't know, a 5th degree polynomial, if this were a 5th degree polynomial, then you would have at most 5 real zeros. Now, when I say at most 5 real zeros, it means it could have less. So even though this could be a 5th degree polynomial, which it is, it does have 4 real zeros. So it fits that definition. It totally does. Now, what's interesting is right here, and this is something that I am going to write down into our notes today. A turning point occurring on a 0. A turning point occurring on a 0. That's what this thing is doing. It's a turning point directly on top of the 0. In our notes today, I'm going to write this down. That's a repeated 0. That's a repeated 0. Let me see what these numbers are. So it looks like positive 4. It looks like positive 2. It looks like negative 1. 2, 3, 4. Looks like negative 4. Looks like I could possibly have those zeros. Let me write those in a better way. So it looks like negative 4. It looks like negative 1 as a repeated 0. We'll deal with that in a minute. It looks like positive 2. It looks like positive 4. Those look like the zeros that I can see on this particular function. But keep in mind, those are zeros. Those are not factors. Those are not factors. The negative 4 would produce a factor of x plus 4. The negative 1 would produce a factor of x plus 1. The 2 would produce a factor of x minus 2. And the 4 would produce a factor of x minus 4. And, as I said today, that negative 1 is a repeated 0, meaning a repeated factor. Now, in terms of this particular problem, again, your questions and answers were shuffled, so I can't just say, hey, it was this letter or whatever. But let me scroll down a little bit, show that answer. You can see the answer right there. There's the x plus 4. There's the x minus 2. There's the x minus 4. And there's the x plus 1 with a square on it, indicating that there's 2 of them being multiplied together. Again, this is just practice. You guys, this is the first time you've seen this information in 6 days. I guarantee you that over Thanksgiving break, you guys were not just studying your notes over the past 6 days. So please do not feel bad about not doing as well on that quizzes as you would have hoped or liked, because I anticipated that. I needed you to see where you were at. Let's skip to a different problem. Let's see. I'm going to skip this multiplicity of 0 thing. How did you guys do on that one? Question 7. Ho-ho, there we go. Okay. All right, let me go down to question 7. Quest 7. There we go. Now on question 7, they're asking you which of the following, scroll down a little bit, Here we go. Which of the following could be the equation of the graph shown? Which of the following could be the equation of the graph shown? Now, something I want to point out immediately. Because of the end behavior, the degree must be odd. The degree must be odd. It has to be an odd degree. And since it is an odd degree, it immediately eliminates those two choices. Why? Because those two choices had a degree of 2. Those two choices are gone. Goodbye. See ya. I don't know. If you wanted to, you could try to factor the choices that you have there. Or, if you were so bold, you could bring up the graphing calculator that is on your Chromebook. And you could try to immediately, let me just try to bring, well, I got way too many windows open right now. Yeah. Where are you? There you are. I got this installed on my computer. Haha. Come on, go faster. There we go. I got this installed on my computer, and it's kind of nice. So let me bring this up, and let me bring this up. There we go. So the equation x cubed, 6x squared, 9x. Okay. X cubed. Oh, that's not an x. Come on. X cubed. Oh, my word. I don't like this. Plus. There we go. Oh, my word. What in the world's going on with this thing? I hate this so much. I can only imagine what you guys have to deal with. 6x. Oh, my word. Did it really just do that to me? No, I'm closing it. I'm closing it, and I'm bringing up my own calculator because I trust it so much better. There, much better. Oh, my word. Oh, goodness gracious. Okay. X cubed plus 6x squared plus 9x. I'm going to just take a quick peek to make sure that I typed that in correctly. Yes. Let's take a look at the graph. Swing, swing, swing. Clearly, that's not the answer. If I change it to a minus 6x squared, there it is. It has to be that one. It has to be the x cubed minus 6x squared plus 9x. Now, obviously, you do have graphing calculators at your disposal. Other options that you have for this particular problem, you could try to factor those two things. You could try to factor by doing some synthetic division. I mean, one of the easiest ways to factor this is by taking out a greatest common factor and realizing where those zeros should be, because once you take out a GCF, you get it down to a quadratic, and then the quadratic you can factor even farther. But this one, you could eliminate choices immediately. Give yourself a 50-50 chance, or plug in those equations into your graphing calculator and see where it goes. Let's see what else we can do. That was question 7. Let's talk about question 8. Oh, yes, here we go. Question 8. Click. It's a little hard to see. I apologize. I'm going to write the equation on the board a little bit bigger so you can see it and what we're dealing with, because this is everything to do with end behavior. But this is the function negative x cubed minus x squared plus 5x. It is a third degree polynomial, meaning yes, it has opposite directions for the end behavior. But furthermore, it has a leading coefficient that is negative. And since the leading coefficient is negative, that means that the end behavior, odd degree, negative leading coefficient, should look like that. So it eliminates those two choices. It immediately eliminates those two choices. Again, these are different things that you could do to try and give yourself a 50-50 shot. And then in the end, throw the equation into your graphing calculator and see which one matches. Now, if I had to take a guess, I wouldn't really even try to take a guess. Yeah, I really wouldn't. What I would try to do, personally, I would try to factor this thing. Oh, interesting. Nice. Yeah, so it has to be this one. It has to be A then, yeah. Again, that's most likely what would happen if you threw that into your graphing calculator. There's a reason why I know that, but I'm not going to get into the details now. I'm going to save it for my notes. But there is a reason why I know that the answer has to be A. The graphing calculator will easily give you that answer for that problem. Let me click on the thing and actually just confirm that. Click. Yep, there it is. A. That was a little hard to see. Yeah, this one's going to be hard to see as well. Oh, goodness. I really hope it wasn't that small on your screens. Gross. Was it really that small on your screens? Ugh. Can I zoom in? Okay. Yeah, I guess this kind of helps a little bit. Oh, that's so gross, though. Okay. We'll give it a shot. Yeah. Sometimes that does happen. I do apologize for the smallness of the questions. Which is the graph of the polynomial with the function p of x equals x minus 1, x plus 1, x minus 4? So, he put his nose up to the screen. Sorry. If you're looking at this problem, again, they're saying which is the graph of the polynomial with those factors. Now, again, process of elimination. This produces an answer, a 0 of positive 1, negative 1, and positive 4. You can easily find what the zeros of the function are once it is factored. You set each of those binomials equal to 0 and solve, and you can find your answers. Now, this one is a possibility. This one, nope, this one can't work. That one can't work. I'm going to cross it out. And that one can't work. I'm going to cross it out. The reason why they don't work is because they don't have the proper zeros. They gave me negative 4 and negative 4 as one of the zeros. Sorry, positive 4 because you set it equal to 0 and you solve. So it has to be one of these two that I have not crossed out yet. It comes down to end behavior. It comes down to end behavior. One has an end behavior where I should really not put a line like that, but whatever. This leading coefficient is positive because it's sloping upward, and this leading coefficient is negative because it's sloping downward. If you look at the factored form, right there, it's in factored form, it's a positive, which means it has to be this one. And again, we'll talk about this today. I'm going to give this a little bit of notes on this in a little bit. So I got to talk about repeated zeros, and I got to talk about the factored form that they give you with the multiple exponents. Those are two things I want to talk about in notes in a little bit. But that's why the answer was the way it is. A lot of these problems are very convoluted end behavior problems. They are. End behavior is a worthwhile topic. It is. The notation for end behavior, in my opinion, is not really worthwhile. But again, it's one of those things that they're going to throw at you. And I want you to be aware of it. So, let's see. Oh, here we go. Number 11. Boop. Number 11. Write a polynomial that has zeros at 1, -1, and 0. 1, -1, and 0. 1. That binomial that I just wrote at the top of the board has a 0 of positive 1. -1. that that binomial that I just wrote has a 0 of -1 and 0. If you have x as a factor, 0 is a 0. Let me repeat that. Put a little more emphasis on it. If you have x as a factor, then the number 0 is a 0 of the function. A little strange. I know the phrasing is off, right? A polynomial of least degree that has those zeros, but in reality, it's like, oh, you're telling me all I got to do is multiply that junk together? Yeah, you do. If you distribute that x and then do a little FOIL action with these two, x cubed plus x squared minus x, these two cancel, leaving me with x cubed minus x. Oh, it's this one. Huh. Interessante. Again, we'll cover that in a little bit. This is just reviewing. This quizzes did not count against you. As I said when we started, we do have time to get this stuff done. Show that answer. There it is. All right, let's see what else I want to talk about. Oh, interesting. Okay, so on this one, we did a little better on end behavior than this one. This one, only one person got this one correct on number 13. Whew. Interesting. Yeah. Yeah, let's talk about that. On this particular problem, ladies and gentlemen, it is a 6th degree polynomial. It is a 6th degree polynomial, which means that the degree is even. The leading coefficient in front of the 6th degree, the leading coefficient is a +1, meaning that the end behavior should look something like that. But this problem, as I said they'd throw at you, is in regards to the notation. As x goes to the right, the function goes up. As x goes to the right, the function goes up. Which one is that? This one fits that category, and this one fits that category. Yeah, the arrows that they were using were a little strange. It's their formatting or whatever, but it's the same notation. It's the same exact notation. Let's talk about the left side behavior. The left side behavior, as x approaches -infinity, let's rewrite that. There we go. The function also goes up. Yeah, that's this one. Again, the notation was a bit off on that. There was only one person that got that one right, apparently. Whew. Again, it's been 6 days. I get that. I totally get that. We're going to get practice. This is part of that practice that we are seeing. Don't you worry. Don't you fret. Don't you cry into your computer screen. Let me see here. Oh, nice. Yeah, that one we've talked about. I'm going to come back to that. Haha. Nice. Nice. Oh, this one. Yeah. I'm going to come back. Let's talk about this one. Yeah, I just showed the answer there. How many x-intercepts would a polynomial of degree 4 have? How many x-intercepts would a polynomial of degree 4 have? I'm sorry. You don't know that it has 4. It has at most 4. It could have less. It could have less. How many real solutions, x-intercepts? It can't be determined unless you know what the equation is or what the polynomial looks like on the graph. Ooh. It would have exactly 4 solutions if you counted complex and repeated solutions. But I digress. Let's see. That one I'll talk about Oh, here we go. Here's a good one. Number 18. Number 18. Which of the following must be true? Which of the following must be true based on the way the graph looks? Based on the way that graph looks. Well, first of all, I know it has an odd degree. It has an odd degree. Immediately, just by looking at it, I know it has to have an odd degree because of the end behavior. Now, what degree is it? It has a degree of exactly 3. It has a degree of at least 3. It has a degree of at least 5, exactly 5. These two are eliminated. Because based on the end behavior, you just know whether it's odd or even. You don't know exactly how many, or you don't know exactly what the degree is. It depends. Now, how many times does it cross or touch the x-axis? It hits the x-axis once here, once here, once here. I mean, they are like hitting. Oh, let's talk about turning points, though. Ooh, turning points. 1 turning point, 2 turning point, 3 turning point, 4 turning points. It's got 4 turning points. By definition, 4 turning points means that you have at least a 5th degree polynomial, because the definition came down to if the degree was n, then you could have at most n minus 1 turning points. That's why the answer has to be this one. It has to be at least 5. Oh, I love those problems. Okay. With the time that we have left, because I have about 10 minutes and I want to knock this out real quick, I'm going to ask you to have those notebooks out and open. I need you to write down some of this information. There's a couple of things, obviously, that I've mentioned that I need you to have. There we go. Cool. So today is the 1st. We made it to December. And this is graphing poly continued. Graphing poly continued. Good for that. Now, a couple of things. If a turning point occurs on the x-axis, then there exists a repeated 0. If a turning point occurs on the x-axis, directly on the x-axis, then there exists a repeated 0. Something to keep in mind. Something that could help you with identifying various graphs in the future. Now, in factored form, a repeated 0 could be expressed with exponents. And let me show you what I mean. It makes more sense if I show you an actual example of that. Now, I want to emphasize in factored form. In factored form. Example. Let's say that you found the zeros of the function to be 2, 1, 1, -3. Clearly, there is a repeated 0. Clearly. Now, the factors would be x minus 2, x minus 1, x minus 1, and x plus 3. Those would be the factors of those zeros. And you would have to account for the repeated 0 having its own factor. But when you wrote it as a function, you could write it in the following form. X minus 2, x minus 1 with a square on the outside. There's the exponent. And x plus 3. It's kind of nice. It's kind of nice. In fact, because of something like this, you could easily determine what the degree of the polynomial is supposed to be. You could easily determine what the polynomial degree is supposed to be if you had a form like this. Let me go back to, and I'm going to write this into our notes. Let me go back to one of the problems from the quizzes that actually does something like this. Let's see here. There we go. Now, this was a problem that you didn't have this kind of verbiage behind it, but that's okay. I'm going to write down some information from this, and I'm going to switch the screen over. So select the polynomial whose zeros in degree are given. The zeros are -5, multiplicity of 3, 9, multiplicity of 2, -2, and 4 with a degree of 7. Flip. Oh, you can't see it. It froze like my heart. There it is. Write that down. Now, on the quizzes, it used the words multiplicity. And what that really means is a repetition. There's a repetition. They're saying that the -5 is a repeated 0, but I'm telling you it repeats 3 times. The 9 is a repetition of 2, and then the -2 and -4 are just sitting there. And the degree is 7. Now, if you think about it, this happens 3 times. 1, 2, 3, 4, 5, 6, 7 zeros. There are 7 zeros if you count repeated solutions. And they told you in the problem that the degree was 7. Now, I would not expect you to know how to do this on the quizzes from today. I would not expect you to. But knowing the information that we just talked about, you could easily figure out what the function's supposed to look like. Now, a 0 of -5 has a factor of x plus 5. But as we just said, it could be expressed, repeated 0 could be expressed with that exponent. It's x plus 5, x plus 5, x plus 5, repeated 3 times. X minus 9 would be repeated twice. X plus 2 and x minus 4. That would be the function. Now, I'm not actually going to multiply this out. This is still in factored form. I'm not going to multiply this out only because that's not what the problem wanted me to do. Now, keep in mind, degree of 7. If I did, I'm not going to, but if I did multiply all this out, this would end up being an x cubed. This would end up being an x squared. This is an x. This is an x. If I multiplied all those out, it would end up with x to the 7th power. And that would be my largest exponent. Now, if I flip back to the quizzes, this was question 17. So let me view this. Where are you? Yeah. 17 would put us here with this question. select the polynomial whose zeros and degrees are given. Well, according to everything that we did, it looks like it can't be that one. It can't be that one. And it can't be that one. It's got to be this one right here. Yep. That's exactly what we wrote down. X plus 5 to the third, x minus 9 to the second, x plus 2, x minus 4. Let me double check. I can click that thing. It'll show up as a green little check mark. Chop out. Yep, and I'm correct. I like being correct. So here's what's going to happen. We're going to spend more time with this, of course. We're going to spend more time with this. Now, I may throw an assignment at you, like a homework or something like that. I may do that before I leave here today. It'd be due before the end of the week. That assignment would not be something that I would stringently grade. It'd be like the homeworks. Homeworks are typically like, you do them, But we are going to get more practice with this because the assessment is not until the end of next week. Now my bell's going to ring. I'm going to run out of time. Thank you guys for joining us. And we'll see you next time. Oh, couldn't get all the notes. Tell you what, I'm going to leave the screen up real quick. I'm going to flip my screen back over. Yatta. There we go. Was that the page of notes that you couldn't see? For the rest of you, I'm not teaching anything new anymore because the bell just rang and the class period technically is over. Gather your stuff from underneath your desks and get out, obviously. But I don't know if that was the page of notes, the first one. Let me bring that there, make that a little bit more viewable. I'll stay on the live stream for a few moments just to make sure you have that written down, and if I need to move it, because again, I know that ball of light is, but yeah. Oh, you guys, yeah. See you guys. Yeah, bye. Yeah, leaving. Bye. I think the ball of light is covering this word form in factored form. And this is why I have concrete notes, because if I didn't have concrete notes like this, I'd just be erasing everything all the time, and I don't like that. Did you get it? Got it. Cool. All right. I'm going to sign off then. See you guys. Have a good day.